Welcome to this segment, and in this segment I'm going to talk about storage devices. So we have talked about input device, we have talked about output device. The next thing that we need to know is how data is going to be stored in your computer system. Now in this space we are going to define what storage device is. We will talk about different types of storage device, and also we'll be able to find the difference between some different storage devices that belong in the same class. So stay tuned up to the end so that you can be able to know how to store data in your computer system. Now the first thing that we're going to talk about is the primary storage. Now the primary storage is basically, from the word primary, it implies that it is something that is really needed. A primary means something that is really needed, essential, is an essential storage. So every time we talk about an essential storage, it's like the main memory. So the main memory is directly accessed by the CPU. So the set of instructions that need to be processed must be loaded in the random access memory, or is going to be loaded in the main memory. Yeah. So this this main memory is the one that hold the current instruction that is needed by the CPU. Okay. So we talk about the operating system. We realize that there's some kind of idle pages that can be stored in the hard disk. But once that instruction is required by the CPU, must be loaded in the random access memory, or the main memory. Okay. Now when we talk about random access memory, why do we say that it is primary? Again, another reason for why we say that the main memory is primary is because of its speed. So if you need data from the random or from the main memory, it is quite easy compared to data that has been stored in the secondary storage or any other storage device. So that's why we need it so much, because of speed and also because of its accessibility. So those are the two reasons why primary storage, we call it a primary storage. Now in the primary storage we have got two types. We have what we call the random access memory, and then we have the read-only memory. Talking of the random access memory is that all the current data that is being used on your computer system is held or is being held or reside in this device. All the data that you are going to use or is being used on your computer system, be it the operating system, be it the application programs, be it the data that you're currently using, all this information is held in the random access memory. Another thing that I need to mention is that with the random access memory is volatile. Why do we say so? It's because it requires power for you to be able to use, or for you to maintain the stored information. So once the power disappears, everything that has been held in this particular device also disappears. So you cannot be able to retrieve information that has been held on this random access memory. Okay, so that's why we call it volatile. Now going further, we talk about the read-only memory. So read-only memory is mainly used during the boot up process of your computer. So it holds the small programs such as the firmware that is stored in the ROM chip on the hardware device. So e.g. we have got the BIOS chip, okay, and they contain instructions the computer can use in performing some basic operations required to operate hardware devices. Yeah. So every time you press the power button on your computer, the first device that is supposed to be visited is the read-only memory, because it contains the firmware, and then the firmware contains the instructions of how the computer is supposed to be started. So it's a very important device, because it can be able to tell us how to start up a computer, and in case it develop any kind of corruption, that's why you realize somebody telling you that I'm going to flash the random the phone. What is going to happen is that it's going to reset the firmware, remove all the instructions that are there, and then start to reprogram again that device. That's why we talk about flashing. So that is where that concept came from. Another very important thing about the random access, the read-only memory, is that it is non-volatile. So what it means in this case, that the content stored on this device, even if the computer is switched off, it can be maintained. So the information stored on this device, it can be maintained even if the computer has been switched off. That's why it is mainly used in the boot up process, so that in case you switch on, all the information that has been stored there can be found. Now cache, we have what we call cache memory. A cache memory is a high-speed access area that can either be a reserved section of the main memory or a storage device. Now, these memory units that we are talking about, they have been categorized depending on in terms of speed. Now, the first one that we have there, we have what we call the cache memory. So we have what we call the level 1 cache memory, and then we have level 2 cache memory. Level 1 cache memory is found within the CPU. The level 1 cache memory is found within the CPU. The level 2 cache memory is found on the motherboard. It is embedded on the motherboard. Now, why do we have different types of memory units? It's because we are trying to optimize the performance of the computer system. So if in case you use a more slower memory unit, the more slower the computer will be, because the CPU will have to step down every time it requests for instructions. It has to step down its speed so that it can be able to communicate with a certain device. Now the manufacturer thought about this, and then they decided to come up with a more faster memory unit that can be able to communicate with the CPU at the same speed that it is required of it. That's why it introduced what we call the cache memory. Now in case the data that the CPU is looking for is found within the cache memory, we say that that is a cache hit. A cache hit implies that the data that you're looking for to be processed, it is found within the cache memory. But in case that data is not found in the cache memory, it is going to be looked in the random access memory, and that is what we call the cache miss. The cache miss means that the data is not found within the cache memory, and therefore it needs to be looked into the random access memory. Okay, so that is exactly what happens in this space. So in order for you to reduce maybe the loss of computer time, or maybe to reduce the speed of the computer, you can be able to use a high speed memory unit so that you can be able to optimize the performance of your computer. Now cache fits in that scope very well. The second type of the storage device is what we call the secondary storage. Now in this space we talk about it is not directly accessed by the CPU because of the speed. So it is quite slow, and therefore the CPU cannot be able to access that. Now computer uses its input-output channel to access secondary storage and transfer the desired data into the intermediate area in the primary storage. So I've said that in order for the data that has been stored in the secondary storage to be used, that data must be brought into the primary storage. So it's not possible for the data to be processed while it is in the secondary storage. That data must be loaded into the primary storage. Now there are two types of secondary storage. We have what we call the hard disk, and then we have what we call the solid state disk. Now the hard disk is here, it has already been shown. We have the read-write head, we have the disk platter, and then we have got the hard drive casing. You can go to see there. So in this disk platter, we have what we call the sectors. We have what we call those pathways that in order for you to store data, you need to know where is it stored. So we have the tracks, we have the sectors. So data is being stored in those tracks, and there is some mechanism in which data is stored in this setup, of which you cannot be able to talk about it in this tutorial. But basically it is just to tell you that data is stored in the tracks, and we have got the sectors and how you can go to choose a sector. We have what we call the seek time. We have got all that information in this space. But basically this is one of the secondary storage device. And then we have we can have some kind of description, and we are saying that it is a thin but rigid inflexible disk made up of highly polished metal. The surface of each side of the disk is covered with a substance that can be magnetized. Okay, thereby allowing data to be stored on both sides on a magnetized or an unmagnetized spot. So the surface of the disk is divided into a number of concentric circles, and I've talked about the tracks. Okay, so data in that space, that is where data is going to be stored, in those tracks. Then we have the solid state disk. So with the solid state disk is non-volatile storage that employs integrated circuits rather than mechanical, magnetic or optical technology. So it's just the use of ICs. So there's nothing like movable or parts of this particular device. So nothing movable, nothing magnetic, nothing optical, only ICs that are being used. So they are also referred to as they do not have any movable part. I've already explained that. Now the solid state disk, basically it uses what we call the flash memory. Yeah, so flash memory is similar to that of ROM memory because we have said that it's non-volatile. There are some differences between the solid state disk and that of hard disk. So you can pause the video and then discuss with your colleague the difference between the hard disk and the solid state disk. Go for it. Alright, so I hope you have discussed with your friend on that space, but basically I can show you some of the differences that are found online. So these are just the differences that I've been able to get, that with the solid state disk is that it is a solid drive and no movement occurs while it is functioning. But when you talk about hard disk, is that it is a moving drive and the hard disk spins when it is functioning. You can be able to listen even to some of the desktop. They have that sound that is being produced when you're processing data. So that is the hard disk, showing that kind of movement, seek time, trying to find a certain data that has been written on that. It is faster in processing speed, but this one is slow in processing speed. The hard disk is slow, but the solid state disk is fast. Talk of low latency. This one has low latency. So low latency basically means the amount of time it takes for you to find data. So it doesn't delay so much when you're dealing with solid state disk. You can find the data more immediately compared to hard disk, which has high latency. When it comes to capacity, CDs, SSDs for computers are available at 120 GB to 4 TB capacity. But when you talk about the hard disk, we have got the capacity starting from 250 GB to 14 TB. Silently it can store a very large amount of data. In terms of read-write time, it takes a very short time in the solid state disk, but in hard disk it takes a longer time in the read-write. Compared to solid state disk. So these are just some of the differences between those. You can be able to see on your screen, and then in terms of cost, how costly it is. You can talk of power consumption, in terms of weight. We have this one is heavier. Hard disk is a little bit heavier compared to solid state disk, and you've been given there those parameters. So kindly go through this. You can see on your screen. You can be able to pause your video as you can be able to see, and then you can be able to know each and every one of them. Going further to our slides again, we move to the next part, and that is the tertiary storage. Talking of the tertiary storage, it applies what we call the robotic mechanism, which will mount and dismount removable mass storage media into the storage device. So talking of that, we have what we call the magnetic tapes and the optical discs. Now, under this scope, we talk about the compact disc. So a compact disc can be able to store up to 700 MBs of data. Now, in this device again, you can be able to store things like video clips, softwares, and sound. Now, when you talk about the CDs, again, there are three types, or they come in three forms. One, we have what you call the compact disc read-only memory. Now, with the read-only memory is that it can only allow you to read, but it cannot allow you to write on it. So once data has been written on that particular disk, you cannot be able to add any data on it. Now data is encoded and read optically. Data in this case is just read using the light. Now with a low intensity light, remember we have got two types of lights in this case. We have what we call the high intensity light that is mainly used to rub or to erase data that has been stored on this device, and you can as well be able to use a low light intensity, which is mainly used to read. So if you increase the intensity of light, you can be able to tamper with the data that has been stored in there. But if you use low light, it means that you just want to interact with the data that has been stored there. Now this data is stored in what we call the bits. So bits, basically in this case, it means little depression formed by the laser burning into the data layer when the CD is created. Now those bits that are being created during the process of storage of data, that is where data is stored. Now the lens is just the part between the bits, the smooth surface. That is what we call the land. So we have got this, remember we're talking about the tracks, we have got the tracks on it, on this particular device. And on this track, during the process of storage of data, the bits are being created. So the bits, that is where the data has been stored. Then the smooth surface, which is what we call the land. So the land is always interpreted by a 1, and then the bits is having interpreted by a 0 bit. So 1 is where we have 1. When the laser beam, the laser enters a bit, then it is no reflection, which is interpreted as 0 bit. Yeah. So that is how you can be able to interpret these two. Very good. Now continuing to the next part, we say that with the compact disc recordable is that they are coated with a special dye which changes color to represent data when burned using a laser beam. So once data is burned on this CDR, it becomes read-only. Automatically recordable is a read-only medium, because once data has been written there, it cannot be, maybe another additional data cannot be written on it. Then we talk of compact disc rewritable, so allows the user to record, erase, rewrite new information, just as one would use a floppy disk. So how do you delete? You just use the high intensity light, laser light. It melts down and levels out the marks that were made during the laser burn. So remember, I've said that during the laser burn, basically what happens is that the bits are going to be created and the lands are going to be created. But if you want to level up everything, you just use a high intensity laser light. Now in this process, after you have done that, you erase everything that was there previously. You can be able to store the new data into this device by using what you call the low intensity light, and then you can burn in the new data. Now we have digital versatile disk. Now in this space we talk about it can store a very high amount of data, up to 17 GB. So what happened in this case is mainly used to do what we call recording of motional pictures, high end or high definition emotional pictures. It can be stored in this. You can also be able to have better sound and also picture qualities than compact disc. Why do we use it? Why do we say that DVDs have got high storage capacity? One is that the tracks are closely together. So I have said data is stored in the tracks, and therefore the tracks are closely together. Number two is that some of the DVDs are double-sided. Double-sided means that it can be able to store a large amount of data. Number two is that the bits are closely together, and therefore you can be able to store more data once you have more bits. That's like something that we should also be able to capture in this space. Going further, we have what we call the optical card. It resembles the magnetic ink recognition, character recognition card, but now data is read and written optically on a strip. So they are mostly used in banking and other business organizations to record customer details. So this one is mainly used in the banking sector. Then we have the optical tape. So it's a magnetic tape. It's similar to magnetic tape, only that data is stored on it by using of the optical technology, like the magnetic tape whereby you store data using magnetic technology. So that's the difference between the two. Offline storage, finally, we have what we call also used also known as disconnected storage. It is a computer data storage on a medium. It has a computer storage medium, computer data storage on a medium or a device that is not under the control of the processing unit. Okay, so this is something that you can disconnect and then you can be able to plug in on demand. So it's not something that is supposed to be fully embedded on your computer system. You just plug it into your computer system when you want to use it, and then remove it once you are done using it. Now, it must be inserted or reconnected by a human operator because a computer can access it again. So that one just depends that if you do need it, you are connected, but once you have done using it, you just disconnect it from your computer system. Examples of this is what you call the floppy disk. We have the zip diskette, we have the USB flash drives, and then we have the memory card, just to mention a few. And here we have got a diagram that can show you those devices I'm talking about in this space. Now, those are some of the hardware, some of the storage devices that you need to do in this space. So I hope you have been able to understand about the storage devices and how you can be able to use them in your day-to-day life, which one is the most directly accessed by the CPU and which one is the least accessed by the CPU. So thank you so much for watching. Kindly subscribe to my YouTube channel to support me, and also you can turn the notification button on so that when I create the next content, you'll be informed. Bye bye for now.